This video is on balancing redox reactions. So there are a few steps that we need to follow to balance redox reactions. First, we'll write half reactions. Then we'll balance non-oxygen and non-hydrogen atoms in each. We'll balance oxygens by adding water, balance hydrogens by adding hydrogen ions. We'll balance the charge by adding electrons to the more negative side, cancel out and reduce, combine half reactions, and then check that our reaction is balanced. So we'll start with our example. And the first thing we need to do is assign oxidation numbers so we can write half reactions. So I have Cr2O7, overall charge of -2, Mn plus 2 goes to Cr plus 3, MnO2. Here, oxygen is always -2, so that means chromium has to be +6. Manganese, the ion, is its charge. Chromium, the ion, is its charge. Oxygen is always -2, therefore manganese must be +4. Chromium we see is going from +6 to +3. Oxygen is staying the same. Manganese is going from +2 to +4. Chromium from +6 to +3 is gaining 3 electrons. Manganese going from +2 to +4 is losing 2 electrons. So that'll help us write out our half reactions. So we first have Cr2O7 -2 is gaining 3 electrons to make Cr plus 3. And then we have manganese plus 2 is losing 2 electrons to become MnO2. Okay. We then want to balance these out. So if I have 2 chromium here and 1 here, I need to add a 2. I'm not worried about my oxygens yet. And I check this one. 1 manganese here and 1 manganese here. So now I go back, and because I've doubled this here, I had 2 chromiums, each with a +6 charge. Each chromium loses 3 electrons, gains 3 electrons to become chromium plus 3. But I'm becoming 2 here, so I need to double this to be 6. So that means I have the overall charge here of 6 times 2, so that's +12. I need to get to be +6 from here. So here I had an overall charge of +12. On this side, 2 times +3 gives me an overall charge of +6. So that means to get from my overall charge of +12 of my chromium on my left side to get to an overall charge of +6 of my chromium on my right side, I had to have really added 6 electrons. Okay. Manganese is all 1 to 1 to 1, so we don't need to worry about it. Now what we want to do is we want to balance our electrons. So 6 electrons here and 2 here, so I'm going to multiply this whole reaction by 3. So 3 Mn plus 2 goes 6 electrons plus 3 MnO2. Okay. I'm going to add these all together. Cr2O7 -2 plus 6 electrons plus 3 Mn plus 2. That's everything from this side of my reaction. I put it all together down here. And now on my right side of my reaction, I have my 2 chromium. I have my 6 electrons and my 3 MnO2. Okay. So that part should be review. Now what we need to do is we need to balance our oxygens by adding water. I have 7 oxygens on my left side, 2 oxygens on my right side. So therefore, I need to add oxygen to the right side of my equation to equal 7. For doing this, I add a water, and I add however many waters I need. Each water supplies 1 oxygen. So 7 here. 3 times 2 is 6 here, so I just need 1 oxygen added. to balance the hydrogens, I need to add hydrogen ions. So you notice on the left-hand side, I have no hydrogens. On the right-hand side, I've just added 2 hydrogens. So that means over on the left, I need to add 2 hydrogen ions. Now I will go ahead and combine everything and cancel out anything that's doubled. So things that are the same, well, hydrogen's only on my left. Cr2O7 is only on the left. 6 electrons are on the left and on the right, so those cancel out. Then I have 3 magnesium plus 2, and that's only on the left. And same thing, my chromium ion, my manganese 4 oxide, and water. So I put it all together. To get my total balanced reaction. 2 hydrogens, 2 hydrogens, 2 chromiums, 2 chromiums, 7 oxygens, 6 here plus 1 more makes 7, 3 manganese, 3 manganese. Okay. Go ahead now and try the U-try problem. Pause the video, try it, and then take a look here in a minute, that way you can see how to do it. Alright, for the U-try problem, we're going to start by checking for our oxidation. HNO3, I-1, makes NO2 plus I2. We first assign oxidation number. Oxygen is always -2, hydrogen is always +1, so nitrogen has to be +5. Iodine has a charge of -1. Oxygen always -2, so nitrogen has to be +4. Iodine, elemental form by itself. Hydrogen, we don't even have it on the right, so we can't worry about it. Nitrogen goes from 5 to 4. Iodine goes from -1 to 0. Nitrogen becomes more negative, so it gains electrons. Iodine becomes more positive, so it lost electrons. So we write our half reaction. HNO3 gained 1 electron to become NO2. I-1 lost 1 electron to become I2. Okay. Notice that our electrons are already balanced. So we go up and look at the numbers or the elements that we were trying to look at that were being oxidized and reduced. 1 nitrogen here, 1 nitrogen here, 1 iodine here, 2 here. So we added 2. So that means we need to double our amount of electrons from 1 to 2. Okay. We need our electrons to balance. So we're going to multiply this one by 2. So I get 2 HNO3 plus 2 electrons goes to 2 NO2. I add them together. 2 HNO3 plus 2 electrons plus my 2 I-1 goes to 2 electrons plus I2 plus 2 NO2. Okay. Now I need to go ahead and balance my oxygens by adding water. 2 times 3 gives me 6 oxygens here. 2 times 2 gives me 4 oxygens here. So I'm going to add 2 water molecules to my right hand side to have my total water or my total oxygens be 6. Now I can balance my hydrogens. 2 hydrogens here. On this side, 2 times 2 gives me 4 hydrogens here. So to balance that, I need to add 2 hydrogen ions to my left side. I could go ahead and cancel out anything that happens on both sides. which in this case are my electrons. So I end up with 2H plus 2HNO3 plus 2I minus 1 yields I2 plus 2NO2 plus 2H2O. And when I double check it, I see that it's balanced. 2 hydrogen plus 2 hydrogen is 4. 2 times 2 gives me 4 hydrogen. 2 nitrogen here. 2 nitrogen here. 2 times 3 gives me 6 oxygens here. 2 times 2 is 4, plus 2 more is 6. 2 iodines, 2 iodines. So I'm balanced.